I'm going to update it. It's mostly done, so you can start working on it if you want to. So the file which you will get if you go to the folder projects on Blackboard is this one. Yeah. Okay, so I'll update that. So really the project has two stages. The first stage is trying to get you to understand the code, and I've done most of the work. You have to just work on two functions, which I'll talk about in a bit. Okay. So you download this code from Blackboard, run it. It's a bit slow. I just accelerated the speed of the ball, but don't run anything, don't touch anything, just run it, and you can see that the ball is there, the paddle is there, but it's not programmed to detect the ball. And I ensured that it stops moment it reaches down. In the code, there are a bunch of variables which are defined using caps lock, and these are global variables, sort of constants. And I'm not talked much about global variables, but global variables are variables which can be accessed by any function. So normally what you do is when you have functions, you pass variables as arguments by putting parentheses, right? Here you don't have to do that because all turns out instead of repeating them again and again, passing through functions, much easier to define them as global variables. There are other variables which are not under caps lock. These are variables which are needed by various functions, but these change as the game proceeds. Right? So game over, for example, I've set it to 0, that is game not over, unless a certain condition is met, the ball reaches the bottom of the screen. So the heart of the code is basically just 5 functions. That's everything. Those 5 functions: init data, init figure, those, and move ball, move pedal, refresh plot are the 5 functions which make the game possible. I've written on init data. It just initializes the data variables. The init figure initializes that figure, that screen. If you want to check things out, what I would do is just comment this part of the code and then run the code again. So you see, when I commented out, the ball did not move. It initialized that screen. So that's how you can check parts of the code. So uncomment. The move ball, move pedal is the ones which you are supposed to program yourself. Move. Okay. Okay, so what I've done here is, in this function, basically, the velocity of the ball is set, is something which is defined. I'm trying to update the position of the ball, the x position, and so one of the methods called Euler's method, where you take the velocity, you multiply it with dt, and then add it to the current position of the ball. So ball x plus ball vx times dt, and you do that for x and y. Okay, so what that does is only moves the ball, but it doesn't do detection of the ball. So what you need to do is, in this part of the code, you got to tell the ball to do something when it hits. So first you got to detect the walls. Like there are 3 walls: up, left, right, and then of course the pedal. So you have to detect the location of the pedal or the wall, and then once it hits the wall, you need to do something with the velocity. It needs to redirect its velocity. So I've given you how exactly that redirection should be done. It's basically follows from what you learned in collisions in dynamics, right? When you come this way, you should have the angle of incidence equal to angle of reflection, and basically there's a bunch of commands in the write-up which tell you what to do. So that's what you do with the move ball function. Move pedal basically moves the pedal. Right now it's set. Okay, so let's check this out. So after you run this first time, you can try to move. I'm moving the right and left arrow key. You can see that once I move the left one, it just keeps going with a certain speed. Move the right one, it just keeps moving to the right. So what's going on the background is I basically set the speed, which is Vx, so the pedal only has an x speed, and basically I move the pedal, keep moving the pedal, and that right is basically, I just keep a track of the left, so there's a pedal, I keep track of the left part of the pedal, and the right part is just the left part plus the width, that's the second part. Anyway, so what, right now, if you just run this code and you let the pedal go, it'll keep going. In fact, it'll just go into the screen. Yeah. You don't want that to happen. You want it to stop once it hits the wall. So you got to again detect the left wall, right wall, and make it stop. Okay, so that's your first part. It is due in 2 weeks. You get that part to work, and I've explained everything I said here is right here. I've tried to be as clear as I could be. These are some of the variables in the code to help you get started, and really the way you learn is by playing with them. So once you get that going, once you get the basic version going, which is basically the pedal moving, it detects the walls, the ball moving, hits the walls, then you have to program the advanced version, which is really an open-ended exercise. You can pretty much do whatever you want. I require you to do 3 things. One of them has to be, you got to add some visual element to it. So it could be you could have, the simplest thing I can think of is over here you could put a paddle over here, a fixed paddle, and every time the ball hits that paddle you can give a score. There's just one suggestion. You could have 5 pedals here. You could have a red, green, blue, and you get a higher score if you have the red. I don't know. You could have a scoring criteria, so that would be considered as something, an addition you make. You could, I've done this before, it makes the game more challenging.